Thank you for having me today. We'll talk about an experience we have done in Telia company and are trying to continue with in other areas than where this pilot was done. Some history of IPv6 and the mass market in Telia company. Not very well known, but since 2011, Telia has had 6 RD in all of their newer gateways. So all customers in the Nordics have had the possibility to go and enable IPv6. The first year between the IPv6 day and the IPv6 launch, we put up some special DNS servers and registered them with Google to attract some IPv6 traffic. Because back then in 2011, there was no Quad A records on the big service providers, or content providers, should be. Not really a lot of customers enabled this. Really not a lot. So there's been no traffic on this. Almost no traffic. Then some years ago, we decided that our fixed access platforms needed a major redesign. So the old service design is based on multiple VLANs per customer, and customers has 4 or even 5 IP addresses, IPv4 addresses. Something that has been dragged along since QoS was done with PVCs in ATM DSLAMs. So it has some drawbacks if you want to make an application on your smartphone that talks to your set-top box, or if you want to make a call and want to use the voice over IP quality, and you have these 4 IP addresses and fixed ports on your home equipment in the bridge case. So some of this has been solved in strange ways, so you sort of have that today anyway, but we want to go to a more simple design, modern QoS, and 1 IP address per, at least 1 IPv4 address per customer, then a bunch of IPv6 addresses. Also a motivation is that Telia has been installing DSL and fiber FTTX networks for the last 20 years or so. Some of this equipment are getting old, and there's no support for lots of stuff, and there's different supports. So we want to make a model where we move intelligence out of these old access nodes. So that's why we came up with a new design. Each customer has their own Q&Q tunnel. They only get 1 IPv4 address, a bunch of IPv6 addresses. And as much as possible, we move the features into a centralized BNG, at least more centralized than compared to having 70,000 FTTX switches. You move it into 300 sites around the country. So it's not like we're moving into a design where we have 4 BNG sites in all of Sweden. But this was basically the new design. What we decided with regards of IPv6 for this design is we use DHCP v6 for both for the WAN link and for the prefix delegations. There is some options also to have like a link local address on the WAN link, but it complicates device management if you want to do that later on with IPv6. In par with what was told yesterday on 690, hopefully, or RIPE 690, we decided to use a /56 for prefix delegation, so all residential customers get a /56. And we have a /64 for the WAN link. And then we use big pools. People want to separate the pools at these 4 nibble points for easier reading IPv6 addresses humanly. So that's why we went for /40. Could have maybe went for /41, but there is a bunch of IPv6 addresses still available. /48 for WAN links. This problem by prefix delegation, that is a bit different from IPv4, where you actually have a subnet behind the customer's residential network at home. So today your IPv4 address, that it can change, and it doesn't really matter for your equipment behind. If you change your IPv6 prefix delegation, all your equipment behind your gateway needs to change IP address also. There is mechanisms for this. You can set lifetimes for different subnets, but it's complicated, and cheap IoT devices, if they even have IPv6 support, they don't follow all these things. So it's important that you keep your prefix delegation. So what we do, instead of fixed assigning it to each customer, there is a feature to keep the lease for 30 days after the customer has turned off the equipment. So it has to be a very long vacation if you change your prefix delegation. So that's how we solved that issue. Security considerations that we made. There was earlier this morning a lot of talk about this DDoS and how much trouble that is. So you can imagine that it's for a big operator in this region at least. We did not want the risk of just enabling IPv6 on our customers, and then all their PCs or IoT devices was available from the entire world. We feel that's something that they actively need to decide. So we have in the CP, we have a stateful firewall that is inspecting the packets and will not allow incoming connections. Then also the same things for IPv4. You have unicast reverse path forwarding. You have, so hopefully nobody will spoof a lot from our network. What we also did is abuse logging. We have updated that to support IPv6, which was actually in most cases just a matter of making sure that the length field was long enough for the long addresses. And we also updated our DDoS platform to make sure that we were on track with that if attacks are coming on IPv6. The work we did in the residential gateway is we are blocking all incoming connections, and what we are working with our vendors to implement is to have the possibility to make incoming connections. We are not there yet. There is, instead of UPnP, there is a different protocol that also works for IPv4, PCP, or part of that PCP can be made in use to enable IPv6 pinholing in a way. We have also looked into, there's a draft from Swisscom, I think, where they actually do open a lot of ports incoming, and there's a list of ports that should be closed because they are known for various DDoS or attacks. We are not considering putting that on as default, but we are considering, or we've requested to have that in the software of our RGVs, so customers can go in and select, I actually want an open IPv6 internet connection. We also set up IPv6 for remote management, tier 69, tested it. We are not using it, but we think it works. QS-wise, especially for older access platforms that has no understanding of IPv6, this is a channel that you can't prioritize your neighbor discovery in upstream in your access network. You can actually do it on the upstream of the customer because the CP or the RTV understands QS for IPv6 and can do prioritization. But the access network doesn't know what it is. It will just put it in best effort. But we see this as a minor risk, as the upstreams are rarely saturated in our network. Everybody wants constant content from somewhere, so it's the downstream. And there we can, even on older access nodes, we use either MPLS COS bits or 802.1p bits for marking the packets, so they will be the important packets. And what in a residential network, what we see as important on the internet is something like DHCP, ARP, neighbor discovery, because if they break, the entire connection goes down. So it's mostly those that we are prioritizing. For our TV and VoIP offerings, currently there is no IPv6 plan. Something to be aware of when you're doing calculations on how to scale your BNGs. Different vendors, they calculate different. Some can take as much as 4 sessions for a mixed IPv4 WAN prefix delegation. Some can go lower, and if you disable features, you can go as low as 1. It's different on different vendors. You're welcome to come and ask me if you want to hear our experience with the specific vendors. When we did this actual migration, we moved all the customers to a new BNG during a service window. Typically, that's a rerouting of MPLS soda wire. Beforehand, we set down the least times of the old IPv4 sessions to something like 5 minutes, and we move these soda wires to the new BNG. And then within a few minutes, customers will get new IP address and call home to their TR69 server. The server will notice they are now on the new access or BNG platform, do the changes for the 6 ID, disabling that, enabling native IPv6, and also enabling native IPv6 or enabling IPv6 on the LAN side. So during this service window, we enabled for all the customers that had a router delivered from us since 2011 also. We enabled IPv6 by default. There is still an option for people to go into their gateway and disable it, but every time we upgrade software, we enable it again. We want them to run IPv6. Yeah. Overall in the organization, it's surprising how few problems we've had. Of course, there's been few minor hiccups. We ran the first initial pilot with 25,000 customers for 2-3 months, and there was absolutely no issues. It was not until we ramped up a bit, we found minor issues with Akamai's DNS implementation. Did not do geolocation really correctly on IPv6. So some clients ended up in a small private data center that had some a small Akamai cache down there in Germany somewhere. And that data center noticed that they did not want to serve all our customers and put in severe rate limiting. Or maybe the DDoS system did, I don't know. Some other problems we have is that sometimes Google content does not work at a specific cache cluster. And then you can have this problem on IPv6, and then you disable IPv6, and it works on IPv4 because you go to a different cluster. But it also happens the other way around, that it doesn't work on IPv4, but it works on IPv6. So it's not really, but that's the kind of problems that we have faced. And then not all of this pilot is from Denmark, and not all of the Danish accesses is our own equipment. So we also rent like bitstream accesses, and a few had very old equipment that was blocking neighbor discovery. Instead of doing with multicast, if you don't know what you should do with multicast, you should flood it in an access network like that. They just dropped it. Some nice statistics. What we achieved from this pilot. It's more than a year ago, just a few days more than a year ago. But when we did this, it's also always fun to see statistics. And at that point, Denmark was, when we started, Denmark was very, very low on IPv6 penetration. There was almost no clients, and what we achieved was to get 80% of the IPv6 eyeballs in Denmark. So we were quite happy with that. Some other APNIC claims that 50% of our users are IPv6 enabled. It's I know the user counts, and that's for the fixed. It's too low, but we also have a large mobile base where they are hiding behind some netted addresses that APNIC can't see. Some interesting statistics from all our fixed customers where IPv6 is enabled. I looked up what is there actually any traffic running on this, and it proved to be 29.5% of the traffic was actually IPv6. So there is content out there. Some months ago, I heard from a Polish mobile operator where it was close to 70% of their traffic that was IPv6 for their APN traffic. So it's time to move on. So the conclusion of this that I would bring onto you is that just get it done. I know there is some of the Swedish operators that are a bit further than we are in Denmark. And I'm working within Telia company to continue this in Sweden and Finland. So we are working hard to do some IPv6 rollout together with some other changes, or these same architecture changes for the access platform. Yeah. I don't know if there's any questions. That was a quick run through of our experience.
So we have some time for questions. Anyone on V6 deployment? There's a question right there at the back.
Hello, Alexander from Carmen. Do you see any potential in actually activating legacy platforms with native V6, like ADSL, for example?
We have done that in Denmark because ADSL is still a platform where there is development. It's not sure that we will do that in Sweden, as the focus is more to move customers to fiber. But it's working. This is 60,000 of these customers or something are DSL, and even back to the old, some very old platforms.
You should do that in Sweden as well.
I will bring that forward.
Okay, a question right at the front, please.
Thank you. Jan George from Slovenia. Thank you for this brilliant presentation, and it's quite encouraging to see big operators deploying IPv6. But when you move forward and enable IPv6 by default for everybody, I hear operators around the world saying operating 2 stacks is expensive and complex, so we are removing IPv4. This discussion already started. Do you have any plans for the future about the transition mechanism, how to go to IPv6 only in your access network?
No, it's difficult to convince my colleagues. I bring it up every time there's a huge discussion about IPv4 depletion and small subnets and all this crap we are we're doing. Yeah, I would like a design where we had pure IPv6 and then you had some residential gateway that does 4 to 6 to 4 or something like that. I think they are doing that in Deutsche Telekom, or I've seen some presentations on that. I don't know if they're actually doing it. But I have no experience with it, but I think it's an interesting technology. And especially on mobile, that's I mentioned this, I can't remember the name, but a Polish mobile company. It's all major mobile phones nowadays run IPv6, and you just have a 6 to 4 gateway. So it's a no-brainer on mobile, and we have test environments, but there's no set plans for. But it's easing up within the company as this LTE forces people to know about IPv6. Yes.
Okay, one question in the middle, please.
Yeah, Michael Abramson. Yeah, you seem to be doing everything right here. It's good work.
Thank you.
What about, you said mobile in passing. What about doing anything IPv6 related in mobile across the different mobile networks? Or, I don't know, are they completely separated in the different countries, or is there any commonality between them?
I'm not working with mobile, so I've heard talk about the coffee machine, around the coffee machine, but so they are pretty similar, the networks, and they are rolling out IPv6 for VoLTE, but that's a different PDP context in the mobile phone. But I have pushed some of these guys, and we have set up some test APNs for this, but I've not heard that we are rolling anything out. There's no plans for that.
Yeah, okay. That's the same frustrating answer I get from the customer support here in Sweden. So,
yeah.
So that seems to confirm that.
We have very few people trying to push this internally. It's hard. But,
right.
Yeah. Thank you.